Do it.
Okay. Hi.
Hey.
Chapter 2, solving equations. One step this time. Spoiler alert, you're going to do 2 steps later.
And then multi.
Multi-steps. What?
We believe in you.
Yep, but we'll just start with 1. Okay. So, let's get that thing out of the way.
Trying.
Okay. So, the reason that we can solve one-step equations has to do with properties of equality.
Right.
We have addition and subtraction properties of equality. You really don't need to know that, right?
Not
really. But so basically, if you are adding on one side of the equation, you're going to use addition on the other side of the equation. Or, for example, you're
equality for all.
Yay! That's where that equivalent equations comes into play. So again, you guys did this in 7th grade a little bit. So yeah, let's get started and show you how it works.
The thing that you'll just keep hearing us say is what you do to one side, you must do to the other.
Mm-hmm.
And that's where that comes from, is the property of equality.
And we will also talk about what is on this slide, inverse operation. It's whatever undoes something. So like obviously it's the opposite operation
Of what is shown.
In the problem. It'll make more sense when we start.
Okay.
Okay, so ultimately, our goal is to isolate the variable or get the variable by itself. So this s needs to be all by its lonesome self on the left side of the equation.
So what is in the way of s right now?
Is that 15? It's 15. A positive 15.
Mm-hmm. Because there's no sign in front of it.
Right.
So the opposite of addition is?
Minus, subtraction.
So guys, you can double check that in your calculator. You just type in 15 minus 15. If it comes out to 0, you're good. If it comes out to 30, that means you went the wrong way.
Oh, okay. I was like, why do they need to check 15 minus 15?
Well,
okay.
It'll get more challenging.
Okay, so 15 minus 15 equals Zippo, so we can cross that out. What's left on the left side of the equation is s equals, and then we're going to solve 42 minus 15. I probably should have grabbed a calculator. Oh, we got one right there.
Yeah, right here. Wait for it.
There it is. 42 minus 15 is 27. Probably should have been able to do that in my head. 27. So that is your solution. S equals 27.
Now, the really cool thing about this is we said S is 27. So you can write out 15 plus and then plug and chug this into there to see if it does in fact equal 42.
Well, let's check.
So you just grab your handy dandy calculator. 15 plus.
Whoop. No.
Whoop.
15 plus 27.
There we go.
Boom!
42 equals 42.
Awesome.
And then I like to do this.
For your check. Fantastic.
Okay.
Okay.
You guys think you can do it?
I think you can.
Okay. Pause us.
Try it out.
Come back. All right, so let's look at the first steps that we have for these. So again, we're trying to solve for x here. This says plus 13. We need to get rid of whatever's on the same side as x.
So you're going to undo that addition with subtraction.
So you should have subtracted 13. Yep, fancy word is inverse. And your answer is x equals 14. Okay, your answer is not just 14, it's x
equals 14.
Yep. Over here, what do we do?
Subtract 2. I really like the green. It's awesome. All right.
That's a good one.
So the 2's cancel. Oh, sorry.
No, I just forgot to mark them off on both.
Okay, so 2's cancel, so I have negative 6 minus 2. So it's going to become more negative. Negative 8. Y equals negative 8.
There you go.
Awesome sauce. Okay. Oh.
More practice.
Those are the same exact practices.
Okay, good.
So we can skip it.
Okay.
Okay. Solving an equation using
new word.
Using
new word.
Addition. Are we already done? No. Okay. So what is the solution of this? Okay, so now we have negative 12 plus x equals 17. X needs to be all by its lonesome self. We got to get rid of that negative 12.
So you just ask yourself the same thing that we did before.
How would you get that negative 12 to equal 0?
Right.
So I'm going to add 12.
Plus 12.
And plus 12 on the, whatever you do to one side, you got to do to the other.
Negative 12 plus 12, nothing. Bring down
your x. 17 plus 12 is 29.
There you go.
Awesome. Okay. Now, how can you tell what to add or subtract to solve each equation? Well, you're going to look at it, and if it's minus, you add. If it's
so you do the opposite.
You do the opposite operation. Yeah.
Yep. If something is added to the variable,
subtract that amount. If something is subtracted from the variable, add that amount to each
There
side.
you go.
Okay. So, more practice. Would you please pause the video and practice these? Wait, what about on, oh, I guess it's just adding. Okay,
Yeah.
we're good. Don't let the fractions freak you out. All right, we'll come back in a sec. Hi. Hopefully, you have some answers.
Yep. One thing, guys, that some people think, oh, that's not going to help me.
Stop making squares.
There you go. One thing that some people think is helpful is if you make a straight line down right here, showing that what you do on one side, you do on the other. So you just have to balance that.
It's like a seesaw. Like
Yep.
whoop, whoop.
Yep. Okay, so we're trying to get the m alone, trying to get the variable alone. We see that -8 or -8 is on that same side.
So to undo -8 and get it to go away, I'm going to +8 on both sides, or add 8. Draw my equal sign line.
-8 + 8, nothing.
What's left on that side is m, and then -14 + 8 is -6. Good. Did we get it right? Woo!
Oh, kinda. We forgot to write m equals.
Oh, yeah.
Sorry, peeps.
Well, we did. We wrote m
That's true.
equals. The book didn't.
That's true.
Okay. On the other side, we're going to add 3 halves.
So again, if you want to make that straight line down, feel free. You don't have to.
But if it helps, do it.
Yeah.
Add 3
3 over
halves.
2.
Add 3 over 2. So now, if you need to set this up side to side, so 3 over 2 plus 1/2, do that. It's not going to hurt our feelings. Equals y. So I have common denominator, so that's going to be 4 halves equals y. 4 divided by 2 is 2.
And then just remember to put your variable first and then your answer.
Awesome.
I think we can do this.
Okay. Okay, now we're going to do this with multiplication and division. So if there's multiplication happening to the variable, we will divide to
Right.
get it to go away.
So again, you're just doing the opposite operation.
Okay, so what is the solution of 2x equals 3/5? So I know that multiplication is happening in between the 2 and the x. So I'm going to divide to get the 2 to
Undo
go
the
away.
multiplication. So I can say divide 2 over here as well.
Okay, so cross out the 2's. And x is all by itself. And now we have 3 over 5 divided by 2. So when dividing using fractions, you multiply by the reciprocal. The reciprocal of 2 is when it's flipped over, the inverse of that. So 3/5 times 1/2. Go back in time and remember 6th and 7th grade, multiply straight across. So
3 times 1,
is 3.
5
5
times
times
2.
2 is 10. Can I reduce that?
Nope.
Nope, because 3 is a prime number. And it does not go into
Should we make it a
10.
decimal?
Nope,
Why not?
because this problem was fractions.
Right. It has to end in the form it started with.
Yes, if there was decimals in the problem, we could do that.
Right.
Okay.
Okay.
Could you solve by multiplying both sides by 1/2? Well, isn't that
Yeah,
what we
that's
did?
just did.
Mm-hmm.
Okay. So yes, sure can.
Okay. Oh, go. Oh, wow.
There we,
Whoa, whoa, whoa. Okay,
Oh, there you go.
there we go. Solve an equation using multiplication. Okay, so what's happening to the x right now is it's being divided by 5.
Yep.
So this is where we're going to multiply by 5. And that's fine, that's good. Okay,
Is that good?
yep, and then those 5s cancel out diagonally and the x is left all by itself.
So over here, again, you just have negative 12 times 5.
No, oh yeah, it is. I was going to say it's -5. Okay, negative 12 times 5 is what? -60?
Yep.
Good.
X equals -60. Again, as a reminder, you can check this at any time. You just plug in -60 over your other stuff.
Equals -12. And when I do, -60.
So,
Negative. Oops, let's clear it. So,
is it 60 negative on this
I think so.
Okay.
Yeah.
Divided by 5?
Divided by 5.
Negative
12. We did
so
it
now
right.
we're good.
Good. Okay. What operation can you use to undo division? We already talked about that. We're using multiplication to undo division.
Yep.
And then look at this question at the bottom. Are x over 5 and 1/5 x equivalent expressions? Explain. Yes. Because there's an invisible 1
There you go.
right there. So it's 1x over 5 or 1/5 x.
Yep.
Same song and dance, friends.
For those of you that want it shown, there it is.
There you go. Okay. Solve equations using reciprocals. Ooh, I love it.
I do
Guys,
too.
reciprocal is a word you need to
We
know.
will use it a lot, a lot, a lot.
A reciprocal of something is when, well, it's basically the flipped over version of the fraction, but it basically means that when you multiply something by its reciprocal, you will equal 1.
Right.
So,
So for an example, if we have, let's say 2/4 times 4/2.
if I multiply that out,
Mm-hmm. Well, red won't work on this.
4 over 2 is the reciprocal.
Mm-hmm.
If I multiply it out, I'm going to get 8 over 8.
Yep.
Which is equal to 1. So
That's why the reciprocal is so cool.
it's amazing.
Yep.
Okay. So let's use reciprocals here. What is the solution of 5 over 2x equals 15? Well, I have to get rid of that 5 over 2.
Right, because you're trying to get x down to
1x.
1x.
Mm-hmm.
That's pretty good.
That was amazing.
Yeah.
Okay, so we're going to multiply by the reciprocal like we just showed you to get it to equal 1.
What you do to one side, you have to do
To the other. All right, so those 2's cancel diagonally, and those cancel diagonally. Ultimately, basically, that's going to equal 10 over 10x, which 10 over 10 is 1.
Right.
Okay, so now we have x equals
What's hidden under the 15?
a big fat 1,
You got it? So 15 times 2
30,
over,
5.
and reduce that down.
Okay, yes, you have to reduce. That would be 6. Awesome. Okay, question on the side. Will the product of a number and its reciprocal always equal 1? Yes,
Yes.
because that's what reciprocals are.
Mm-hmm.
Definition of reciprocal.
So going back to this, one thing we didn't talk about was if you have 2/5 times 5/2, we went ahead and said it reduces down to 1.
Well, I said it equals
It
10
does,
over 10.
yeah, but you can also ask yourself, okay, 2 goes into 2 once,
Mhm.
5 goes into 5 once. And so that's goes back to what you've already learned. Just
You're reducing prior to doing the work. Okay,
there we go.
are we about out of time? No. Well, almost. We have one more slide left.
Okay.
Okay. Using a one-step equation as a model. Okay, Rob is driving at 40 miles per hour. Stacy is driving 3.5 times as fast. So, how fast is Stacy driving?
Okay. Oh, geez.
Okay, well, we know 3.5 times is going to be 3 over 2 times something, right?
Well, we have Rob
Okay.
is 40
miles per hour. So let's do 40 miles mph. Okay. And then we have Stacy, which is 3/2 times Rob.
So times as fast, so they're saying as Rob.
Mm-hmm.
So what do we do here?
Then it has to equal something.
Yep. Well, it doesn't tell us what to equal. So we have to use our
Brain coral.
brain coral. Remember that one? Yeah. Okay. So then you have 3 over 2
Mm-hmm.
times 40
Right.
equals Stacy.
Mm-hmm. So let's do it.
Okay. Hidden under here is a
The
1.
one.
3 times 4, D.
Is 120 over 2 equals Stacy. 120 divided by 2 is 60. So Stacy would be going 60 miles per hour.
Remember to have your label.
Mm-hmm. It must have mph or miles per hour.
Yep.
Okay, let's keep going. Okay, when solving a, I thought we were doing
no summary.
no summary.
JK. Hey, do the lesson check. It's at the bottom of this page.
Mm-hmm.
Okay, and we will talk about it tomorrow.
See you on the flip side.